Hello students and welcome back. We are starting a new unit today and it will be a continuation, as always, building onto our knowledge of functions. And so far we have dealt with linear functions and we have dealt with parent functions and transformations of quadratics, cubics, absolute values, square roots, and rational functions. But we've only looked at the parent functions and what the parent functions have, and then how to transform them based on a new function that is given to us. And so we're going to dig a little more deeply into some of those types of functions. This unit will be all about the quadratics and then the higher powered polynomial functions like your cubic functions, or even higher exponents like to the fourth power or to the seventh power. We're going to learn a lot of basic information about those types of higher powered polynomials. I will go ahead and tell you that this unit is one that you definitely want to have your graphing calculators for. If you are allowed to use it, which you are in this class, it will make this unit much easier. But you've got to learn to use your graphing calculators, and you have to still learn the terminology, learn the vocabulary that I'm going to give you in this unit, because the vocabulary will tell you what you need to be looking for. Doesn't matter if you can use your graphing calculator if you don't know what the terms mean to find them on the graphing calculator. So please make sure you are studying your terms as we progress through this unit. Make sure that you are doing your homework and getting those practice problems in, and then seeking assistance during office hours when you need it. Our learning targets for today, if you want to just pause the video and just kind of skim through those very briefly, I will give you a moment to do that. And in all three of those learning targets, you should notice a repeat phrasing over and over and over again. Every single one of these learning targets mentions quadratic functions or quadratic equations. Okay? This next lesson that we are engaging in today is going to be all about quadratic equations. Quadratic equations, and then all the details that come with quadratic equations. So the first one is I can identify quadratic functions or equations based on the equation and the function given to me. So the short version of that is I can look at an equation and I can tell you, hey, it's quadratic. You should already know how to do this because we covered this last chapter. If the highest power in an equation is a 2, then it's a quadratic function. So you already know how to do that first learning target. It's just going to be more of a review. Our second learning target is I can identify and determine characteristics about the graphs and equations of quadratic functions. So again, we've already kind of touched on this a little bit with the parent function. So we've touched on the key point or the vertex of the parent function that is quadratic is 0, 0. And we've talked about how its domain is all real numbers, so negative infinity to positive infinity. We've already discussed how the range is from some bracket, some value to infinity, or from negative infinity up to a certain value brackets. And that is because the shape of a quadratic function is a U or a parabola, and it will depend on if the parabola is opening up or opening down as to what your range will be. So we're going to add some information to that for today's instructional video, and then some other things. I can apply prior knowledge, so things that we touched on last chapter and even the chapter before, and things that you might have learned in Algebra 1. I can apply prior knowledge of factoring, quadratic formula, and solving for the roots or the zeros or the x-intercepts of functions to quadratic equations. And so 90% of these learning targets are review of what we did last unit and then building on top of what we did last unit. Okay, so what you have in front of you to start us out about quadratic functions is something that you should all be very familiar with. It is the standard form of a quadratic function, where you've got sometimes three terms, sometimes less than that, but you typically see it written in this format of ax squared plus bx plus c. If you used the quadratic formula before, this is the standard form that you had to have it written in. You'll notice that this says a does not equal 0. Okay, don't ever complicate that. Look at this term. If a equaled 0, what would happen to the x squared? 0 times anything is just 0. So if a was equal to 0, then your x squared term would be gone because it would be multiplied by 0, which is just 0. If you don't have the x squared term, then it is not a quadratic function. So that's all that means. You're not going to get quizzed on that or anything necessarily, but that is a part of the definition where for it to be quadratic, you have to have at least one term that has a variable raised to the second power. And that's it. So this way of writing it is what we are going to call standard form. And the reason why we call that standard form is because what you learned years and years ago, when you write something in descending order, meaning the largest term, then the next largest, then the next one, all the way down to the constant, that's called standard form. And that's the way that this is written. This quadratic function format is written as the largest term based on its power plus the next largest term all the way down to the constant. Now I will go ahead and tell you that the textbook that we are using at the moment, which depending on what year you are looking at may be different, but if we are looking at the OpenStax textbook, which for the fall 20 semester, that's the textbook that we were using. A lot of different resources out there will call these formats different things. I am telling you right now, we are going to call this form standard form in our class. Regardless of what your textbook says, we are going to call it standard form. Okay. Now, there are some characteristics of quadratic functions that we need to know as well. Some of these we have lightly touched on last unit. We are going to enhance them for this unit. So all quadratic functions are in the shape of a parabola, meaning that U shape, whether it's opening up or opening down, all quadratic functions are some type of U shape. Okay? And those are what we call parabolas. Parabolas are symmetric, meaning I can fold them perfectly in half and they will fold on top of each other. Okay? So all parabolas are symmetric over something called the axis of symmetry. That's just a fancy name for if I were to fold my parabola perfectly in half, the fold line, the crease in my paper is the axis of symmetry. Okay? And so before we move on any further, take a look at the diagrams down below. You'll see the axis of symmetry as that dotted red line. Okay? And what type of line is this? Okay? Your axis of symmetry for quadratic functions is always a vertical line. Okay? I'll repeat that. Take a look at your image here, both of these diagrams. Your axis of symmetry is that dotted red line, and it is a vertical line. What does that mean for us? Anytime I ask you for the axis of symmetry on a quadratic function, you are going to tell me x equals something. Because the equation of all vertical lines is x equals a number. Okay? So in this situation, whatever the x value is on all of these points on that diagram to the left, okay, there's a bunch of points that are on that axis of symmetry if we were to draw it in. All of those points have the same x value. And so my axis of symmetry would be x equals whatever that x value is. Same thing in the diagram on the right. If I were to plot points on that axis of symmetry, all of those points would have the same x value. And so the axis of symmetry for that graph would be x equals whatever those x values are for each of those points. Okay. Now another thing which moves us into our next point, or sorry, no pun intended, our next fact, if you will, if that makes it a little bit less confusing with all the points and things happening. If you'll notice, that axis of symmetry actually hits the graph in exactly 1 point. I repeat that. My axis of symmetry for every quadratic equations graph hits the graph exactly 1 time. In the diagram on the left, with that parabola opening up, you'll notice that it hits the parabola at exactly 1 point, and it is the absolute lowest point on that graph. In the diagram on the right, where my parabola opens down, you will notice that my axis of symmetry intersects my parabola at exactly 1 point again, but this time it is the highest point on that graph. Okay? That point where the axis of symmetry hits the graph is called the vertex. And that is something that we mentioned, that we introduced last unit when we looked at the quadratic parent function. So now you know a little bit more. You know the axis of symmetry is the vertical line, x equals something, that you can fold your graph in half over. And where that axis of symmetry hits or intersects your parabola is the vertex. Okay? Your vertex will either be the minimum point on your graph, or it will be the maximum point on your graph. Okay? When your parabola is opening up, okay, aka when your leading coefficient is a number greater than 0, so it's a positive value, 1, 2, 5, 25. When your leading coefficient, when that a term is positive, your graph is always going to open up, which means your vertex will always be the lowest point or the minimum. On the flip side of that, literally, the reflected version of that, when your leading coefficient is less than 0, meaning your a term is a negative number, then your parabola is going to open down. We learned this last unit as well with transformations. If that leading coefficient is negative, then that means there is a vertical reflection. And so if I have a parent function that is a parent function that is quadratic, that is opening down, that means the leading coefficient, that a term, is negative, and my vertex is the absolute highest point, or a maximum of that graph, the absolute maximum of that graph. And so here's the really good thing about our class. Because it is virtual and I have no way of monitoring it, you are able to use your graphing calculators, which means you can very easily find the exact location of every vertex that I may give you. However, because there are a million different calculators out there, I cannot possibly explain every way to find the vertex on your graphing calculator. Now, if you have a TI 83 or 84 version, if you have a TI Inspire, or if you are using Desmos, I would be more than happy to work with you during office hours to show you exactly how to find the vertex of every quadratic function that I may give you. So if that's you, if that just rang a bell in your head and you just said, yes, please, I need to know how to use my graphing calculator, pause this video and email me right now and say, I would like to meet with you during your office hours on this day at this time. Make sure that you know my office hours before emailing me. Okay? But once you email me and we set up that time, then we can talk through how to find the vertex using your calculator. the content specific to this course is that I show you how to find the vertex algebraically. And so that is what I am going to do. However, I want to point out that you can find the vertex much faster using your graphing calculators if you have one, or using Desmos. Okay, so let's start with what we already know, or what we are already familiar with. Okay. We already know the standard form of a quadratic function. Again, that is what we are going to call standard form for this class, is highlighted in yellow at the bottom next to the blue arrow. Ax squared plus bx plus c. The standard form of a quadratic function or equation is what we use to solve for the roots or the x-intercepts of a function using the quadratic formula, or using factoring. Okay, so you're familiar with this formula or this format. How do I find the vertex of a quadratic function if it is written in this standard form? Okay, so I have that here boxed off in red down at the very bottom. At the very beginning of this lesson, I told you that there was going to be a lot of terminology and a lot of formulas that you needed to memorize / take really good notes on. Okay? So you'll notice the A term, the B term, and the C term in this standard form. Okay? To find the vertex of a quadratic function in this standard form, I have to know where A, B, and C are located in the formula, because I find the vertex using those terms. So to start out, I find the x value first. I find the x value of my vertex first. Okay. And the way that I do that is by looking at the format, looking at the equation in standard form and saying, what is B? Write it down, and then negate it, meaning whatever it is, make it the opposite. So if it is a positive number, I'm going to make it negative times that number. If B is already a negative number, then I'm going to write it as positive that number. Okay. Divided by 2a, meaning divided by 2 times whatever the a term is. That will give me the x value of my vertex. Then, once I have the x value of my vertex, I can take that x value and plug it in to my function everywhere that I see x. By plugging in the x value, think about it, your x values are input. And so when I input something, something else comes out, or the output. Another name for the output of a function is the y values. Okay. And so again, let me restate that all again. Once I find the x value of my vertex, I'm going to plug that x value into my function everywhere that there's an x, and that will spit out a y value for me, which is why you'll see this in the definition or in the formula for finding the vertex. F of negative b over 2a, or whatever the x value is, plug it in for x and get the y value. Okay. All right, so pause this video and jot those things down before we go any further. So now we have the second way that you can write a quadratic function. This is called, in our class, we are going to call it vertex form. Okay. Vertex form. Now, why would we call an equation vertex form? Okay. Don't ever think it. If we are going to refer to an equation being in vertex form, then I bet that equation's going to tell us the vertex. Okay? And so the vertex form is what's in that first box in yellow. F of x equals a, parentheses, x minus h, close parentheses, squared, plus k. Now, depending on what textbook we are using, it might be called something different. I feel it best to call this format vertex form because it gives you the vertex directly. Okay? Whereas down here in standard form, you have to do a bunch of calculations. In vertex form, you don't have to do any calculations. The vertex is literally staring you in the face when your equation is given to you in this format. So here again, we have some more terminology that you definitely need to study, you need to learn and commit to memory. Okay, when a function is written in this format, we're going to call it vertex form, regardless of what our textbook might say at the time. We're going to call it vertex form. Okay? And the reason why we're going to call it vertex form is because the vertex is literally h comma k. Okay? So let me clarify, because this can be a little tricky. Do you remember when we learned our transformations last chapter or last unit, and whatever was inside of here is actually the opposite? So say we had x plus 2 squared. That actually meant we moved to the left 2, or we went negative 2 to the left. It's backwards on the inside. Well, it's the same thing with the vertex here. Okay? This standard form says x minus h squared. Then the x value of your vertex is the opposite of h. Okay? So let's go back to this example, because this is kind of hard to put into words. You just have to see a visual. Let's say this was our equation or our function, whatever. This says x plus 2 squared. Well, just like our transformations would say, I need to do the opposite of this. I would go left 2 or negative 2. The x value of my vertex would be negative 2. And then the k term, just like with our transformations, that just means positive 3 or up 3. Same thing with our vertex. It is the way it is written, just positive 3. And so that is how we find the vertex in vertex form. Whatever is written here, it's the opposite of whatever's there, comma, k. Okay, so if you had, let's say you had x minus 3 squared minus 8, then your vertex would be opposite of negative 3, which is positive 3, comma, negative 8 would be your vertex. Okay? And that's it. Again, keep in mind, you could just graph whatever function is given to you, regardless of the format, and learn how to find the vertex from there. Okay? What we just saw on an earlier slide is that the vertex is always one of two things. The vertex is either the minimum or it is the maximum. You can find that out very quickly using your graphing calculator as well. Otherwise, you're going to have to remember that if A is positive, then your vertex is a minimum. If your A term or that leading coefficient A is negative, then your vertex is a maximum. Okay? Moral of the story, what I'm trying to tell you is learn to use your graphing calculators, and I'll be more than happy to help you learn to use your graphing calculators or learn to use Desmos, which is a graphing calculator. So that's the new content. Now we just need some practice putting this all together. Okay? So we have two examples in front of us, and for each of these functions I want you to graph and identify the axis of symmetry. I want you to identify the vertex. Tell me if the vertex is a max or min, and then we will rewrite the function in vertex form. So we got a lot going on here. If you haven't picked up on it already from your previous two tests, I would never be able to give this to you as one question. I would have to break this down into probably 5 separate problems. Okay, so all these directions, because there's so many parts to it, this is worth a lot of points. This is the bulk of this lesson This is a big chunk of your new content for your upcoming test 3 as well. So this is really important for you to pay attention to what we are doing. Okay. With that in mind, I want you to pause this video and I want you to try and do the first 3. So back up, use this content to find out the axis of symmetry in the vertex. Remember that the axis of symmetry, remember the axis of symmetry tells you the x value of your vertex and vice versa. The vertex will tell you the axis of symmetry by using the vertex's x value. So it's a two-way street there. Okay? So using that information, you can find the vertex and the axis of symmetry. So you need to decide, is this in standard form or vertex form? If it is in standard form, then you're going to have to find the vertex using this method. If it's in vertex form, you'll use this method. Okay. You can also use your graphing calculators. So pause this video and try to find the axis of symmetry, the vertex, and figure out if it's a max or min. And then we will work through vertex form together. Okay, so that looks like a lot of work on here, but all I did was walk through what I just talked to you about. The first thing I did was look at my function and identify, is it in standard form or is it in vertex form? Okay. And so looking at x squared plus 2x plus 2, that is in standard form, where it is in the format ax squared plus bx plus c. And so because it is in standard form, I have to calculate the vertex algebraically by taking the b term, negating it, and divided by 2 times a. And so that's what you see written right here. And then my next step is, what is b and what is a? So if I come over here and I would say ax squared plus bx plus c, what is your a term and what is your b term? Okay, so even if you need to write it directly above the function and then draw an arrow down, a, draw an arrow down, is 1, and b, draw an arrow down, is positive 2. Hence where I get 2 right here, and then I'm going to negate it for negative b divided by 2 times the a term, which is 1. And then I simplify that. Negative 2 divided by 2 is negative 1. And so that is the x value for my vertex. Now to find the y value, I have to take the x value, which is negative 1, what I just found, and I've got to plug it in to the function or evaluate the function when x equals negative 1. And so I plug it in, and whatever spits out, the output, is the y value of my vertex, which is where I got positive 1. Put those two things together, and that is my vertex location, negative 1, comma 1. So what is the axis of symmetry? The axis of symmetry is the invisible vertical line. So automatically vertical line means x equals something. And it is the vertical line that cuts my parabola perfectly in half. It is also where it intersects the graph at the vertex. And so this question is very easy. What's the axis of symmetry? Well, do you know the vertex? Yeah, the vertex is negative 1, comma 1, right there. Okay. There's your x value, and there's your y value of your vertex. What is the x value of your vertex? It is negative 1. So what is the equation of the axis of symmetry? X equals negative 1. The axis of symmetry will always be x equals the x value of your vertex. So if your vertex is 3, comma 2, your axis of symmetry is x equals 3. So on and so forth. Okay. Now, based on that graph, my leading coefficient, my A term is positive, which means my graph is going to be a parabola opening up. So is my vertex a minimum or a maximum? Based on that visual I've got, it is a minimum. But keep in mind, you could have just graphed it on your graphing calculator and look at what's right there, your vertex, which is at -1, comma, +1. And where's your axis of symmetry? The vertical line of x equals -1. Okay. And looking at the visual of that graph, is my vertex the absolute highest point or the absolute lowest? Is it the absolute max or is it the absolute min? It is the absolute minimum. Okay. So again, hopefully you're seeing using a graphing calculator is going to be your best bet. But knowing the algebra is going to be very important too, especially if your major requires you to take calculus or requires you to take pre-calculus. You're going to have to know this content, and your professor may not let you use a graphing calculator, which means you've got to know how to do this by hand. So we covered the graph, we covered the axis of symmetry and the vertex, we covered that it is a minimum. Now the last thing we have to do is rewrite the function in vertex form. So I want to remind you what vertex form is. Okay. I need to shift some things around at my screen, that way we can actually have some space to work. Okay. So again, let me remind you of the vertex form of a function. Your leading coefficient A, parentheses, x minus h squared plus k. You just need to go ahead and memorize that. You need to memorize that as your vertex form. Why? Because it directly tells you the vertex. Okay. Now what you should already have on your paper is the vertex, might I add. Okay. So the vertex you already calculated, which was at -1, +1. And we can see that from this graph. Okay. Now in order to write that function in vertex form, okay, go back to this form. Remember your vertex is h comma k. Okay, that's from earlier in our notes. And so that means h is represented as -1 and k is represented as +1. What other terms are up here in your formula, in this block, the formula written in black? Okay. You don't have a yet, so we're missing the variable or the term a. We don't have an x, and we don't have an f of x. Okay? If f of x freaks you out, then remember f of x can serve also as y. So those are the three things that we are missing, is we don't have an a term yet, we don't have an x term, and we don't have a y term. Okay? So go back to your graph. Can you determine what that a term is just by looking at the graph? No, you can't. But can you find an x value and a y value? Absolutely. Okay, so look on this graph. Besides the vertex, can you find me another coordinate point? It can be any one that you like. I would suggest picking an exact coordinate point, so don't estimate, like don't pick this and go, I think I know what that is. That looks like -2.8 comma 3.9. Okay, don't pick something that you're estimating. Let's pick an exact value. The only exact value that I see is the y-intercept here, which is at 0, 2. The only exact point that I see that we could use easily here is the y-intercept, which is 0, 2. Okay. Okay. So I'm going to pull that information over here and just call it my other point. Or better yet, let's just go ahead and call it the y-intercept, which we found to be 0, 2. And remember, that can be labeled as an x value, comma, y value. All right. So let's recap. Here it is in vertex form again, y equals a parentheses x minus h squared plus k. But we know what k is. K is positive 1. And we know what h is. H is negative 1. We also went and found the y-intercept, which is an x value and a y value. So now I know that the x value is 0 and a y value is 2. So if you haven't caught on yet, I'm trying to walk you through step by step how to rewrite the function in vertex form. Okay, so if I give you something in standard form and I want you to rewrite it in vertex form, you need to know the vertex and you need an extra xy value or an extra coordinate. The easiest one to find is the y-intercept, and you can pull that straight off of the graph. Okay, now I've plugged all of that in to this step. What is the only term that is missing? It's the a term. That's the only thing that we do not know, and it's the one thing that we have to have in order to write this equation in vertex form. So once you have all of that filled in, you're only missing one term. You can solve for a. Okay? You can solve for a. How do I do that? Well, keep 2 equals, keep the a. What is 0 minus negative 1? Okay. That's the same thing as 0 plus 1 squared plus 1. Keep simplifying. 2 equals a parentheses. Instead of 0 plus 1, that's just combined to be 1 squared plus 1. Keep on simplifying. 2 equals a times 1 squared, which is just 1 plus 1. And now you're looking at a simple linear equation. How do I solve 1a plus 1 equals 2? Subtract 1 on both sides. And so 1a equals 1. Why does that matter? Well, in order for us to rewrite the function in vertex form, we had to have that a term. So now we have y equals a parentheses x minus h squared plus k. Don't worry, we're going to fill some stuff back in. Instead of a, we now know that a is 1. What else do we know about this equation? We definitely know the vertex. The vertex, the k term, is plus 1, and the h term, is negative 1. If you want to go ahead and rewrite that as just x plus 1, you can totally do that. Now, folks, before you fill anything else in, what do we always have to have in order to graph a function? Okay. Look right here. F of x or y equals x squared plus 2x plus 2. What two variables are in this function? X and y. Okay. Look at this one. Remember, f of x is the same thing as y. What two variables are in this equation? Y equals x squared minus 5x. What two variables are there? X and y. We have to have the x and y variables in order to graph a function. So, to finish out this problem entirely, to rewrite this function in vertex form, I want to leave the x variable and the y variable so that I can actually graph it. That is our final answer. So to recap all of that one more time before we try a second example, to rewrite a function from standard form into vertex form, the first step you need to do is, and let me change my colors here so that's very obvious. The first step you need to do is step 1, find the vertex. Step 2, find the y-intercept. You can find both of those by either calculating them algebraically or pulling them off of a graphing calculator. Step 3, plugging in the vertex and the y-intercept pieces into the vertex formula. Step 4, solve for that a term. And then finally, step 5, put it all together, but make sure you leave the x variable and the y variable in order to graph it, in order to plug in x values and y values. Okay. I know that was a lot. That is why you've got homework. We're also going to do another example here in just a second. Okay. Pause this video and rewind if you need to redo this problem, to jot down anything that you might have missed, but make sure you get everything that we talked through and we wrote down on that problem. Alright, so here's your second one, f of x, or remember that's the same thing as y equals for this scenario. Okay. Go ahead, pause this video, jot this example down, and I want you to definitely, you should be able to graph the function just by plugging in x values and getting y values. Tell me the axis of symmetry, the vertex, and then tell me if the vertex is a min or max. And then we will walk through writing the function in vertex form together again. Alright, check your answers on these. You'll find your vertex. I gave you your vertex in fraction form and in decimal form. Since I did not specify in the directions how to leave it, I have to take both. Your vertex is a minimum. Why? Well, 1, I checked the graph, but 2, your leading coefficient, x squared, that coefficient is 1, which is greater than 0, which means this graph opens up, making the vertex a minimum. Your axis of symmetry is the x value from your vertex, so x equals 5/2 or x equals 2.5. One last minute thing before we move to vertex form. On your test, when I ask you for the axis of symmetry, if you do not write that as an equation of a line, then it will be counted wrong. The axis of symmetry is the equation of a line. So for you to get credit for that question, you have to tell me x equals blah. In this case, x equals 5/2 or x equals 2.5. If all you gave me was 2.5, I would mark it wrong because that is just a value. That is not the equation of a line or the equation of the axis of symmetry. Now, moving on to vertex form. We know that the vertex itself for this problem is 2.5, we'll just use the decimals, 2.5 comma negative 6 point, what was it, 25? Double check, I've got it on the next slide. Yeah. So we know that's our vertex. We also know that we need another point, and usually the y-intercept is our best option. Now, if we don't have a graphing calculator for some reason, how do we get the y-intercept? Well, a y-intercept is always 0 for the x value, and then whatever the y value is that spits out. So if you don't know the y-intercept because you don't have a graphing calculator, you've got to find it algebraically, which means you plug in 0 for all the x values, and that will give you your y value, which in this case, looking at the graph, is 0, 0. Okay? So that should be an easy point to work with. Remember that that's an x value and a y value, and your vertex is an h value, comma, k value. Okay? Now, to remind you of vertex form, that is y equals your a term, parentheses, x minus h squared plus k. Now, if you've done what we did last problem and you found the vertex and the y-intercept, all you need to do is plug some things in. So instead of the h value, I can plug in 2.5. Instead of the k value, I can plug in negative 6.25. If you want to make that just minus 6.25, it's the same thing. You're more than welcome to do that. Something else I know, instead of the x variable sitting there, I can plug in 0. And instead of the y variable there, I can plug in 0. Now from there, I want you to pause the video and I want you to solve for the a term, because that is the biggest chunk of finding and writing an equation in vertex form, is finding that a term. So pause this video and find your a term. Simplify this algebraic statement and find a. Solve for a. So when you simplify that down and solve for the a term, you should get very simply that a equals 1. And so now go back to your vertex form, which is y equals a parentheses x minus h squared plus k. It's vertex form, which means we want the vertex to be in there. Okay. So I'm going to put the vertex back in there. Instead of h, I'm going to replace that with 2.5. Instead of k, I'm going to replace that with negative 6.25. Okay. If you want to put just minus 6 1/4, that's fine with me. Okay. We also know that a can be replaced with 1 based on what we just solved. And lastly, we want to leave the x variable and the y variable in place so that we can actually graph this function. Now, for those of you that are using a graphing calculator, you've got one extra step that you can do. You can type this into your graphing calculator, and you can graph the original function, x squared minus 5x. You can put both the original function and your final answer into your graphing calculator and look at what you get. When you graph both of those, you should only see one graph. And the reason why is because they are on top of each other, because they are the exact same thing. If there is any variation whatsoever, if you can tell the difference between those two functions, then you've made a mistake, because the original x squared minus 5x and your final answer in vertex form should be the exact same graph. So you should only see one representation of a graph on your calculator. Alright, moving on. We're getting close, people, I promise. Just trying to be thorough so that we're all on the same page and we're well equipped and well prepared. So just because I know how difficult writing something in vertex form can be, I've included a couple of extra examples for you Now, I provided the vertex and the extra point for you. And so what I want you to do is I want you to jot these down in your notes, and I want you to attempt these on your own now. So we've done 2 different examples together. I want you now to try and attempt a couple of these on your own. I will give you the final answers for each of these 3. And then if you're not sure where they came from, then you are more than welcome to contact me and we can work through those during some scheduled office hours. If you've got it, then maybe just try one of these and check your answers with me, and then you are good to go. If you maybe need a little more practice, then you try these 3. We can work during office hours, and then maybe you try some homework. Okay? Pause this video and see if you can work through these 3 examples. There's your final answer for the first one. Keep going and make sure you try the second one and third one as well. Here's your answer for this second one. Okay, and hang on for the third one. Pause this video if you need to jot any of this down or if you need to try and find where you might have made a mistake. Otherwise, go ahead and attempt number 3 if you haven't already, and I will post the answer in just a few moments. And finally, here is your last one, number 3. Final answer is over here in the blue box. Remember that with all of these, you can check your answers by simply typing this equation into your graphing calculator and then tracing your graph to see if this is really its vertex and if this coordinate point is somewhere on that graph as well. Please make sure that you attempt your homework, ask any questions, seek appropriate help during office hours. There's a lot of people that are just now emailing me saying, I'm sorry I didn't ask for help yet. I don't want you to be afraid to ask for help. That is what I'm here for. We are at midterms, though we do not have a midterm for this class, we are halfway through. We are at the middle mark, if you will. And so I don't want anyone to feel at this point that they cannot ask for help, because I want you to be successful. I want you to understand the content, and I want you to not despise math so much that you don't even want to ask for help or that you've given up. Okay, so please reach out to me. Feel free to ask any questions. Let's set up some time during office hours. Other than that, I will quit nagging you and bugging you. Have a good day. Let me know if you've got any questions. Bye-bye.